Alrighty, so for example 7, we have secant squared and, tangent squared and secant to the fourth. So we can look at this top portion because we have an even secant and we're provided these two orange lines of information. We take the derivative of u, we go back to our college algebra, our Cal 1 derivative box, and we know that the derivative of tangent is secant squared dx. And now our goal is to get secant squared dx out of our original problem, and then we also want secant squared to be everywhere else, and then hope that tangent is the only thing that's left. Okay, so to get secant squared, we need to change the secant fourth to secant squared squared. Okay, so tangent squared is the same thing as tangent squared. So here, this is our secant squared squared, or you could just write secant squared, okay? So we know that tangent is equal to u, so that's going to be u squared. Secant squared we know is equal to 1 plus tangent squared. Our tangent is u, so that's where this u came from. And then our purple part, secant squared dx, is our du. Okay, to get rid of the parentheses, we distribute that u squared. To take the integral, we add the 1, divide by that number, add the 1, divide by that number. And then we add the plus c because we're not evaluating it. Originally we were looking for x, so we go back to our u and plug in tangent x for our final answer.